I hope all of you are doing well. I'm Mr. Ish. Thank you for joining me for this video. We are examining and understanding the antiderivative of this hyperbolic secant function. It has a very interesting antiderivative. We will derive it and we will see it to be the case. When you are doing this, what are you looking at in terms of a function? You are looking at the reciprocal of your hyperbolic cosine. That's what you have, because it is indeed the reciprocal of that. Now look what I'm doing. I'm shuffling things around, or I'm doing an algebraic manipulation. I'm going to do a hyperbolic cosine on the numerator, but I'll also do it in the denominator, but to the power of 2 dx. Think about it. If you simplify this, you end up right over here. But this right here is a reciprocal of that, and we're good. This here is equal to that. It's equivalent to it and it's equal to it. It's just written by means of algebraic manipulation. All you have to do now is a substitution. U is equal to, we will say, a sine hx. Why am I doing sine hx? Because I'm reminded of a very fundamental identity. The hyperbolic cosine square x minus hyperbolic sine square x is equal to 1. It's the hyperbolic counterpart of what the trigonometric identity, you know, sine square x plus cosine square x equals 1. This is a hyperbolic version, except there's a minus in here. When I'm looking at this, I'm looking right here in the denominator. I can do a substitution. Hyperbolic cosine square x is equal to 1 plus hyperbolic sine square x. I'll substitute that right here, and then this will come into play. Look how everything plays out. I have a hyperbolic cosine x dx divided by this 1 plus sine h square x. Now I'm thinking about a u substitution. I've already started out. U is equal to sine hx, du is equal to the derivative of that, which is hyperbolic cosine x dx. I see this right here in the numerator. I see it. And I also see u, and I can do a substitution. What do I end up with? I have here in the numerator du, because du was equal to hyperbolic cosine dx. Right here you see it. And then I have 1 u square. Now when you see this, you're thinking the arctan or the inverse tan, because when you do the derivative of your inverse tangent function or the arctan, you're always getting something like 1 over 1 plus x squared. This is what you have, and this is what I'm seeing. Therefore, the integral of this should give me back the original function, which will be your arctan. That's exactly how we would proceed, and you see it, and we'll use it. So when I'm doing this, I'm getting an antiderivative here of arctan or inverse tan of u plus c. You have nothing more to do other than resubstitute the u, which is this. When you resubstitute it, you end up at your antiderivative arctan of sine hx plus c. For the indefinite integral, this here is your antiderivative, but it's good. That right there is how you come up with the very interesting antiderivative of hyperbolic secant function. That's what I'm showing you here. Have a good day.